Most casual hikers and campers pass right by their first chance at gold. The telltale glint in river gravel. Barely noticeable unless the sun hits just right. Often goes ignored as mica or trash. But in high-yield streams, that shimmer can be the surface trace of a surprisingly dense deposit hiding just inches below. Gold settles predictably because of its high specific gravity, about 19.3. It sinks faster than nearly anything else in moving water. Over years or centuries, that sinking behavior causes gold to accumulate in predictable zones. Inside bends where the current slows, behind large boulders where eddies form, and at the base of natural riffles. In flood years, heavier material gets churned up and resettled, often pushing fresh gold closer to the surface. For trained eyes, a shift in gravel texture or color, especially concentrations of darker sand or pebbles, signals a need to pause and test. Yet even obvious flakes are often dismissed. Many confuse them with mica, which flashes but floats when agitated. Real gold doesn't behave like that. When swirled in a pan, it clings stubbornly to the bottom. It doesn't dance or drift, it sinks and stays. In ideal light, its color also gives it away. Gold has a rich, buttery luster that doesn't fade or shift angles. Unlike pyrite's brassy tint or mica's silvery gleam, native gold shows a warm, oily sheen even in shadow. Missed opportunity also comes from misunderstanding terrain. A dry gravel bar might seem unpromising, but if it sits below a known upstream bend or feeder creek, it could be loaded. Old-timers knew this. They didn't just scan for sparkle. They studied flow, sediment, and how storms reshaped the riverbed. It's not luck, it's reading the land. Modern tools help, but nothing replaces situational awareness. That stray flake at your boot tip might not be a random glint. It could be the visible edge of a layered pay streak compacted just under the overburden. And unlike visible nuggets, which are rare and often spread thin, flake gold travels with its peers. Where there's one, there are often many, if you know where and how to look next. A single flake in a pan isn't enough, unless you know how to read it. The difference between worthless glitter and real gold lies not in how it shines, but how it behaves. And most beginners overlook the two tests that matter most in the field: luster and weight. Start with luster. Real gold shows a muted, buttery glow even in indirect light. It doesn't sparkle, it glows. Under harsh sunlight, it appears soft and oily rather than sharp and reflective. Compare this to mica, which flashes like tin foil when tilted. Pyrite, commonly called fool's gold, has a brassy brilliance that's sharper but brittle. Gold doesn't flash. It gleams with a consistency that holds even in the shade. Then comes the weight. Even small flakes of gold feel heavy for their size. That's not just intuition, it's physics. Gold has a density of 19.3 g/cm superscript 3, nearly twice as dense as lead and over 7 times denser than quartz. In practice, that means gold hugs the bottom of a pan stubbornly when agitated. While other minerals lift and swirl in the slurry, gold stays pinned to the base. The fingertip test is crude but telling. Pick up a flake with a moistened fingertip and tap it gently against a rock. Mica and pyrite will often stick or crumble. Real gold will resist movement. In larger flakes, you can even press them slightly without breaking them. Gold is malleable, not brittle. Try that with pyrite and you'll get fragments, not flecks. Another field method is the scribe test. With a small pin or knife tip, gently press the flake. If it scores or folds without snapping, you're likely handling gold. Pyrite and chalcopyrite often shatter or splinter instead. This single trait, malleability, has ruled out countless false positives across the history of prospecting. Even so, the most reliable way to confirm gold's presence isn't in isolation. It's in behavior during panning. True gold concentrates in the bottom corner with black sands after several rinses. If the suspect material rises or drifts mid-swish, it's almost certainly too light. Only the heaviest elements remain once the lighter silicates and organics wash out. Yet these tests alone don't guarantee value. Alluvial gold varies in purity, with some flakes registering as low as 70% native gold content. That's why context matters. A heavier-than-expected flake near magnetite-rich black sand is more promising than a lone sparkler in silty runoff, especially when combined with the right terrain features. And that terrain is the next filter, the one that separates the truly rich spots from the waste of time. Because even perfect flakes mean nothing if they're pulled from the wrong part of the river. Most gold losses happen before the pan even hits the water. The key failure? Choosing the wrong part of the river. Despite centuries of prospecting, the logic of gold deposition hasn't changed. Water moves gold, slowly, predictably, and with little forgiveness for guesswork. Knowing how to read the river is the single greatest factor separating profitable days from empty pans. Gold is over 19 times denser than water. It sinks quickly in turbulent flow and settles where the current drops off. That's why inside bends of rivers, called point bars, are prime collection zones. Here, the water slows, drops its load, and deposits heavy materials like magnetite, garnet, and crucially gold. These curves become natural traps, collecting flake after flake over decades. But not all bends are equal. You want those with visible signs of energy loss, gravel buildup, exposed bedrock, and lines of heavy cobbles that show where the current has weakened over time. Avoid steep outside banks or straight, fast sections where gold gets pushed along rather than dropped. More subtle are plunge pools and bedrock traps, where a stream flows over resistant stone or a boulder. It scours out a pocket just below. These plunge zones can be small, just a few feet across, but act as gold catchers. If you can feel water swirling in reverse eddies or see coarse gravel collecting behind obstructions, you're near a potential pocket. One of the most overlooked zones is the false channel. These are remnants of the river's older paths, now dry or only seasonally wet. Because gold moves slowly, it often lags behind when the river shifts course. That means ancient high benches above the current stream can still contain placer gold. Old-timers knew this and dug deep pits into those benches, leaving behind tailings piles that still yield today if sampled properly. Then there's the pay layer. Beneath layers of light gravel, there's often a dense, compacted zone where gold finally stops moving. This layer is typically found just above bedrock or hard clay. When panning or sluicing, reaching this bottom layer is crucial. Skimming the surface gravel will rarely yield more than trace amounts. But reading terrain isn't enough on its own. You also need to think upstream. Ask, where could the gold be coming from? Are there known quartz veins, sulfide-rich outcrops, or glacial tills that might be feeding the stream? Is the surrounding geology conducive to gold at all? Granite and schist terrains are more likely hosts than sedimentary flats. Finally, remember water level timing. After spring melt or a heavy rain, gold-bearing gravel shift. The best time to sample is after water recedes, but before others arrive. Exposed riffles, fresh gravel slides, and scoured bedrock reveal concentrations no one saw before the flood. So once you've found the right bend, bench, or plunge point, what's next? You take the first pan, and you look for more than just gold. You look for a shadow that might be worth more than the metal itself. Black sand. Black sand is the overlooked fingerprint of gold's presence. It doesn't shine. It doesn't flash. But when it collects at the bottom of your pan in dense streaks or patches, it tells a story, one of gravity, time, and heavier metals traveling together. And most importantly, it tells you that gold might not be far behind, or already within it. Black sand isn't a single mineral. It's a mixture, typically dominated by magnetite, Fe304, and hematite, Fe203, with trace amounts of ilmenite, garnet, and even lead shot in disturbed zones. These minerals are heavy, often 4 to 5 times denser than water, and they move through stream beds much like gold does. When you see black sand collecting, you're observing nature's own gravity concentrator at work. In practical terms, here's what matters. Black sand almost always settles with gold in river systems. If your pan test produces heavy concentrations of fine, dark grains that resist swirling away, you're in a zone of high specific gravity materials. In active deposits, that means flakes and fines of gold could be mixed right in. In historic or tailings-rich areas, it could mean you're just inches from richer pay streaks. A magnet becomes your best friend at this stage. A simple neodymium magnet, wrapped in a plastic bag or placed in a small container, can quickly confirm if the black material is magnetite. Just sweep it through your pan residue after you've rinsed out the lighter silts. If the grains jump or cling, you've got magnetite, and that's a good sign. It means water has slowed enough in that spot to drop dense particles. But there's nuance here. Not all black sand zones carry gold. Some river systems are naturally rich in iron minerals, but geologically poor in gold. That's where understanding regional geology comes back in. If your black sand is accompanied by angular quartz fragments, rusty staining, or trace sulfides, the odds improve. Especially if you find gold's classic companions, tiny garnet chips, lead fragments, or greenish epidote grains. Some prospectors misread fine magnetite as a signal on its own. It's not. What you want is a co-presence. Black sand with gold in the pan's bottom crease. If you see fine flakes of gold clinging among the dark grains and resisting the water's force, that's your moment. It's what old-timers called color. Black sand also tells you how to dig. If the surface gravels are light in color and low in black sand, move deeper. Denser material and gold concentrates toward the bottom, just above bedrock or within packed clay layers. That transition zone, often just a few inches thick, is the richest part of most alluvial systems. Still, the presence of black sand and even a flash of gold doesn't yet guarantee value. You need a sampling method that confirms you're not chasing a false streak. And that begins with a quick test that reveals a true hit. One pan, one decision, and just minutes to tell you whether to stay or move on. The single most important decision a prospector makes happens within the first 10 minutes at a site. Is it worth digging deeper, or should you move on? The answer lies in a basic, fast pan test that reveals whether you're looking at a genuine pay streak or just attractive but empty gravel. And it's not about finding gold. It's about finding enough of it. Start at the right spot. An inside bend, plunge pool, exposed bedrock groove, or a tightly packed gravel layer near a false channel. Fill your pan with a full scoop, about 10 to 15 pounds of mixed overburden and compacted material. If you're just scraping surface sand, you're already missing the point. What matters is material from just above or within the dense pay layer, where heavies like gold and black sand settle. Submerge the pan fully and begin to gently agitate the material, letting lighter silt and organic debris float off the top. Tilt the pan slightly and swirl water around to help break up clay and loosen fine sediments. Begin washing off the top layer in shallow stages, letting water remove light material while you control the pace. You're not rushing to the bottom. You're guiding material so the heaviest particles have time to settle. A hit is defined by what remains in the last 1 to 2 tablespoons of concentrate. In promising ground, this final sweep should show 3 things. 1. Dense black sand. 2. Angular pebbles or lead fragments. And most importantly, 3. Visible gold. Not just a flake, but multiple specks or a single substantial piece. Even fines count if they resist movement underwater and cluster in the crease of the pan. How much gold qualifies as a hit? For field purposes, 1 to 3 visible flakes per pan is a solid indicator, especially if repeatable in the same zone. Consistency is key. 1 flashy pan means little. 3 in a row with color suggest a workable deposit. In richer areas, 1 pan can yield a dozen fine flakes and a visible picker. But this is rare unless you're near historic diggings or remote, untouched territory. Another field trick. After emptying the pan, rinse it and tap it upside down on a light-colored surface. Any gold you missed will cling to the pan's crease or smear slightly. This can reveal ultra-fine gold that may not stand out underwater. Avoid the beginner mistake of focusing only on visible flakes. Gold dust, the superfine particles that look like dull pollen, is a major component of many placer deposits. If you're consistently recovering flour gold mixed into black sand, especially in quantity, you're still on profitable ground. It just requires different recovery gear down the line. But don't stop at gold. Analyze the remaining heavies. If you see garnet chips, lead shot, or dense minerals that don't respond to a magnet, you're likely in the right density zone. On the other hand, if your final concentrate is mostly mica, light-colored sands, and no magnetics, you're outside the gravity window. Some areas surprise with good color, but no accompanying heavies. That can be a red flag. It may signal residual gold washed from a higher source, not a concentrated streak. In that case, your next test should be 10 to 15 feet upstream or deeper, tracking where the real deposit sits. Nothing sinks hope faster than the moment your gold shatters under pressure. Many new prospectors ride high on the thrill of their first sparkling pan, until they try to press a flake between their fingers and it turns to powder. The culprit? Pyrite, chalcopyrite, and mica, collectively known as fool's gold. Their presence is one of the most common early setbacks in gold panning, and understanding how to distinguish them under pressure and time saves both effort and pride. Pyrite, Fe2, is the most infamous of these lookalikes. It forms in cubic crystals or as glinting specks in shale and quartz veins, with a metallic luster and a brass-yellow hue. It often occurs alongside gold in sulfide-rich systems, which adds to the confusion. But the differences become obvious with a few simple tests. First, the crush test. Gold is malleable. It flattens or bends under pressure. Pyrite is brittle. It crumbles into sharp fragments. If a flake in your pan shatters when pressed between a rock and your finger, it isn't gold. Then there's mica, sheet silicates that flake off in thin, paper-like layers. Mica floats or swirls in water, especially in slow pans. It reflects light sharply but doesn't sink. Gold always settles low in the pan and doesn't shift easily during agitation. A single swirl test can reveal the difference. Gold stays pinned while mica dances. Even trickier is chalcopyrite, CuF2, a copper-iron sulfide with an iridescent yellow tone. It lacks gold's true density and luster, but can cling like it in black sand. Under a loupe, chalcopyrite appears grainy or pitted, while real gold looks smooth, even in rough flakes. Chalcopyrite also tarnishes to blue or purple hues with time or exposure. Gold never does. Another false positive comes from brass or bronze filings in disturbed or dredged areas. These metallic shavings, left by machinery or human activity, mimic fine gold flakes but lack weight. They are magnetic, unlike gold, and often stick to the pan if a small magnet is passed beneath it. Here's where specific gravity saves time. Pyrite has a density of about 5G/cm superscript 3, far below gold's 19.3. In a side-by-side pan test, gold will sink rapidly while pyrite takes longer to settle or drifts in the wash layer. If you're in doubt, compare your questionable flake with a known gold sample or certified picker. The behavior difference in water is unmistakable. Also, Remember the color trick. Gold maintains a consistent buttery hue under all lighting. Pyrite often appears too brassy, too bright, or slightly greenish. Under a cloudy sky or in shade, gold still glows. Pyrite dulls immediately. If you're consistently finding pyrite in your pans, it's not a total loss. Pyrite-rich zones may still carry gold, particularly if the source rock includes quartz or shows hydrothermal alteration. In these cases, gold may be locked within the sulfide matrix or present as fine dust. The smarter move is to sample deeper or nearby spots where erosion could have liberated native gold. False positives aren't failure. They're part of the filter process. But once you've ruled them out and start finding consistent, test-passing gold, the next question becomes clear. How do you process more with less effort? Most prospectors plateau because they treat their gear like a checklist instead of a system. A pan is essential, but alone, it limits how much pay material you can process per hour. That's where a few key upgrades, chosen smartly, not just added blindly, can easily triple your gold recovery rate. The goal isn't to own more tools. It's to move more promising material faster while keeping your precision intact. The first upgrade worth its weight is the classifier, or sieve. By screening out larger rocks, typically with a number 8 or number 10 mesh, you eliminate dead weight before panning. Gold rarely hides in the big cobbles. Classifying down to uniform-sized material increases efficiency during washing and concentrates your effort on gravels that matter. For serious field work, nested classifier sets let you separate material into fractions, coarse, medium, and fine, each with different likelihoods of holding gold. Next, the sluice box, the workhorse of efficient panning. Even a compact 24-inch backpack sluice allows you to process several buckets of material in the time it takes to pan one. Sluices work by harnessing the same principle as the river, stratification by weight. Riffles in the sluice trap gold while lighter materials flush out. Rubber matting with fine texture under the riffles adds a second capture zone for small flakes and flour gold. But gear must match context. A long, heavy sluice is useless in low-flow streams. Look for lightweight, modular systems. Some collapsible sluices weigh under 5 pounds and fit in a daypack. Use natural drops or construct a controlled water flow with buckets if the stream's too gentle. Gravity is your engine. A snuffer bottle and vial kit are underrated tools. After panning or sluicing, a snuffer bottle lets you safely extract gold without spilling fines. Keep multiple labeled vials. One for clean gold, one for mixed black sand and fines, and one for uncertain or test material. This allows for sorting later under better conditions and prevents contamination. Then there's the magnet wand, critical for black sand separation. Once you're down to heavy concentrates, a magnet can pull away the magnetic fraction, mostly magnetite and ilmenite, letting you see hidden gold beneath. This doesn't remove the gold, it reveals it. Always use the magnet inside a plastic bag or tube for easy cleaning. Optional but powerful. A gold cube or mini high banker for bulk work. These systems are better suited to stationary camp setups or multi-day digs where several gallons of pay dirt need processing. Their fine recovery systems can retain flour gold that sluices often miss, but they require a water pump and setup time. For under $200, a basic upgraded kit could include pan, classifier set, collapsible sluice, snuffer, magnet, and vials. Add a shovel, knee pads, and GPS or topo maps, and you're equipped to sample and work most terrain with confidence. But no upgrade matters without input discipline. Every bucket processed must come from a spot that passed the visual, luster, and pan tests. Doubling volume in poor zones only gets you faster to failure. Triple yield comes from compounding smart collection, effective processing, and fast rejection of dead zones. The the tools scale, but the principle remains. The heavier the target, the more it resists movement. That's why, in all upgrades, the test of value is density. And that's exactly where we turn next, with the field methods that prove what you're holding isn't just shiny, but genuinely heavy. When in doubt, trust gravity. While appearance and location hint at value, it's density that proves it. Gold's remarkable specific gravity, roughly 19.3, means that even in tiny flakes, it behaves differently from everything else in the pan. It hugs low, it resists flow, and it settles in ways you can measure. When you understand how to use density as a field test, you stop guessing. You start knowing. The simplest form is the heft test. Pick up a promising flake or pebble between wet fingers and compare its weight in hand to a known sample or similar-looking material. Gold feels heavy. Not just a little, strikingly so. Even a small picker weighing less than a gram feels denser than a lead sinker of the same size. The difference becomes intuitive with experience, but even beginners notice it once they've handled real gold. When flakes are too small to test by hand, turn to water displacement. A quick specific gravity test in the field can be done with a digital scale, a small container, and a syringe. Weigh the gold dry, then weigh it submerged in water, suspended from a thread. Use the formula SG equals dry weight / dry weight, submerged weight. For gold, a reading between 18.5 and 19.3 confirms purity. Lower values suggest contamination or alloying, common in river-worn particles, which can include silver or copper traces. For comparison, pyrite yields an SG around 4.8 to 5.1, while magnetite reads closer to 5.2. In the pan, density reveals itself through motion. As you wash material, denser particles migrate to the lowest crease of the pan and stay pinned through swirls. Lighter particles lift and drift, even if they're metallic. That's why a slow, controlled wash is so telling. Real gold will hold its position even when you tip the pan sharply or agitate the slurry. If the flake moves easily or rises mid-swish, it's too light. This behavior is especially visible in tailing tests. After sluicing or classifying, take the leftover concentrates, typically rich in black sand, and give them one final pan. Gold that resisted capture will still be present if your flow was too fast or your sluice improperly leveled. These tailings tests teach you about recovery efficiency and show whether your gear needs adjustment or your classification was too coarse. Density can also guide where to dig. In ancient stream beds or false channels, look for layers where heavy minerals collect. A clear sign is false bedrock, a hard-packed clay or silt layer just above the actual bedrock. Gold often stops here. It can't sink further, and it accumulates with magnetite and garnet in a tight band. Scratch at this layer. If it releases fine black sand and the pan glows with color afterward, you've found the trap zone. Still, density can mislead if used alone. Lead shot, tungsten, and some alloys used in fishing or ammunition can mimic gold's weight. That's why weight must be paired with malleability and visual consistency. If a heavy flake is hard and brittle, it's not gold. If it's dense and dull under a loop, suspect contamination or alloying. True gold retains warmth in tone, folds under pressure, and leaves a distinctive yellow smear when rubbed on unglazed porcelain. And when all signs align, weight, behavior, and resistance, you're ready to think beyond the pan. Because one good find raises the stakes. Is this a fluke, or have you just found a real, repeatable deposit? To answer that, you need a workflow. One that doesn't waste time, tracks location precisely, and tells you when to invest in lab testing. That field process is up next. It happens more often than you'd think. After weeks of scouting and sampling, a prospector finally hits it big. Multiple grams per day, consistent black sand, repeatable color from every test pan. The concentrates look rich, the vials are filling, and hopes are high. But when it's time to sell, the wind drops out of the sails. The buyer rejects the batch, or offers pennies on the dollar. Why? Because not all gold is equal, and not all gold is usable. This is the moment where many first-timers learn the hard truth. Field success does not always translate to market value. In one case from Northern California, a prospector recovered over 10 grams in a long weekend, flakes, pickers, even a small nugget. But when he took it to a local refiner, he was offered only 40% of spot price. The reason? Low purity and the presence of amalgamated mercury in the sample, likely from historic mining contamination. His haul was real, but not clean. Placer gold varies widely in purity depending on its source geology. Gold in glacial till or from oxidized quartz veins may contain high percentages of silver, which lowers carotidage and melt value. Instead of the expected 22 to 23K, around 91 to 96% gold, some samples test as low as 14K, 58%, in naturally alloyed form. Without an assay or XRF scan, sellers have little negotiating power, and buyers know it. Then there's the form of the gold itself. Flour gold, the fine dust that many rivers produce, is difficult and expensive to smelt. Unless you accumulate a significant amount, usually several ounces, many refineries won't bother with it. Pickers and nuggets command higher value, but only if they're clean, uniform, and uncoated with iron oxide or mineral crust. Raw gold contaminated with sulfides, lead, or mercury can trigger environmental handling fees that further reduce payout. Even location plays a role. Urban buyers or pawn shops are often middlemen, offering 30 to 60% of spot to cover their own risk. To get full market value, you need a direct route to a reputable refiner or assay lab. But most labs have a minimum weight, often 50 grams or more, for economical processing. That leaves solo panners in a tough spot. Not enough to smelt themselves, but too much value to walk away. This mid-reversal forces a recalibration. It's not just about finding gold, it's about marketable gold. A vial of dusty flakes might be worth far less than a single gram of clean, nugget-grade metal. Understanding form, purity, and local buying conditions becomes just as critical as field testing. It also raises a logistical question. How do you prove that your site is worth further investment, whether in refining costs, permits, or scaling up with better gear? That's where professionals switch gears, from random scooping to structured sampling. They grid, they log, they create repeatable data before spending another dollar. And that shift from hopeful digging to strategic mapping is where the real value begins. Serious prospectors don't chase glints, they document patterns. Once color appears in multiple pans, the hobbyist instinct is to dig faster. The professional instinct is to slow down, take notes, and verify repeatability. That's when random luck becomes a viable claim. The method? Gridding the site. A low-tech, high-discipline system that turns chaotic riverbeds into predictable zones of yield. Start by establishing a reference line, typically along a consistent bank, ridge, or river marker. Use tape measure, compass, or GPS to map a baseline. From there, lay out perpendicular transects every 5 to 10 feet, forming a grid of rectangles or squares. Number each point for consistent logging. Each grid square becomes a sampling unit, measured not by what's found, but by how much, how consistent, and how deep. At each point, take a standard volume of material, one full pan or one half bucket, from the same depth. Avoid cherry-picking visible patches. The goal is uniform sampling. Same volume, same technique, same tools. Pan carefully and record not just the gold recovered, but the presence of black sand, garnet, magnetics, and compacted gravels. Note water depth, flow strength, and substrate type, clay, gravel, bedrock. These notes matter more than you'd think. Patterns emerge not just in what you find, but in where and how you find it. When color repeats across multiple adjacent grid points, especially at consistent depths and with similar sediment texture, you're looking at a potential pay streak. If gold only appears in isolated patches, it's likely residual or flash deposited, valuable for a day trip, but not sustainable for a claim. Logging tools vary by budget. A waterproof field notebook works. A GPS-enabled phone with mapping apps, like Gaia GPS or Avenza Maps, adds precision. Flagging tape or small numbered stakes help mark test sites in the field. Some advanced users log coordinates and results in spreadsheets with calculated yields per cubic yard. A move that's essential when planning to scale with machinery or seeking partners. And here's the kicker. Once you have a grid and repeatable positive samples, you're positioned to file a claim or justify the cost of a mineral assay. In the U.S. Bureau of Land Management (BLM), regulations often require proof of discovery before staking a federal claim. A well-documented grid with photos, coordinates, and recovery logs fulfills that burden far better than a vague, "I found gold here" anecdote. In some jurisdictions, gridding is the standard for conservation compliance. Forestry or environmental agencies often want proof that excavation won't damage sensitive zones. Your grid shows responsible sampling, targeted extraction, and spatial awareness. It protects your access and strengthens any future permits or development requests. But gridding is more than bureaucracy. It's insurance. When the river floods or the trail disappears, your marked coordinates allow you to return exactly to where the gold was found, not just approximately. It prevents wasted time, guesswork, and missed opportunities due to seasonal changes. At this point, you've gone from scratching gravel to managing data. But not every terrain supports this approach. Some places yield clean, consistent gold. Others look promising, but resist every test. That's why the next move is knowing where these tactics work best, and where they'll waste your time entirely. Even perfect technique fails in the wrong terrain. Gridding, sampling, and panning work best in regions with a history or strong geologic likelihood of placer gold. But in the wrong setting, all the discipline in the world won't produce more than false hope. That's why terrain awareness isn't optional. It's the gatekeeper to everything else. Let's start with where it works. The best prospects are in active or ancient placer systems. Rivers, creeks, benches, and outwash plains that have transported gold from a hard rock source. Look for areas downstream of known gold-bearing veins, especially quartz-rich zones with visible sulfides or oxidized iron staining. Uplifted terrain, where erosion has had millions of years to wear down host rock, tends to produce the richest deposits. In the U.S., reliable placer gold zones include California's Sierra Nevada foothills, e.g. Yuba, American feather rivers; Alaska's interior drainages, particularly near Fairbanks and Nome; Idaho's salmon and Clearwater systems; Oregon's southwest corner and the Rogue River; Colorado's South Platte and Arkansas River drainages; Montana's western ranges, especially in glacially influenced valleys. In Canada, look to British Columbia's Fraser and Caribou regions; Yukon's Klondike drainage; Alberta's North Saskatchewan River, though yield is typically fine gold. Elsewhere, promising regions include Australia's Victoria and Western Australia goldfields, New Zealand's Otago rivers, South Africa's Barberton area, though largely industrial, parts of Scandinavia and the Urals, where glacial transport played a major role. But where does it fail? Sedimentary basins, where geology lacks the igneous or metamorphic activity needed to generate gold, are nearly always a dead end. Flat, sandy rivers in limestone or shale regions tend to carry light minerals and organics, not gold. Swampy or deltaic environments may have all the right water flow, but without the upstream source, gold never arrives. Another red flag is a stream with no heavies at all. If you test pan after pan and find zero black sand, garnet, or magnetics, you're likely too far from any meaningful source. Gold doesn't travel alone. If the pan holds nothing heavy, there's nothing heavier lurking beneath. Desert washes are a special case. In arid regions like Arizona or Nevada, gold moves not by rivers but through flash floods. Here, dry panning or metal detecting replaces water-based sampling. It works, but only with different tools and terrain logic. Even in gold-rich zones, recent human activity can strip surface deposits. Dredged rivers, hydraulic tailings, or commercially mined creeks may still hold color, but the best zones are buried or dispersed. Without heavy digging or access to virgin tributaries, your returns may stay low. Also consider regulatory access. Some of the most promising terrain, like protected parks, indigenous land, or private claims, is off-limits. A perfectly grid site means nothing if you can't legally extract from it. Always verify land status through official channels before investing time or gear. In short, gold panning works where gravity has had time, energy, and the right feedstock to build deposits. Without those three, source, slope, and sediment, the effort returns nothing but clean pans and confusion. So if you've found your region and confirmed its potential, you can start refining your approach based on the type of gold present. And few materials challenge panners more, or offer more reward, than glacial gold. It's elusive, fine, and unpredictable, but with the right eye, it becomes one of the most promising targets of all. Glacial gold breaks all the usual rules. It doesn't follow river logic. It ignores elevation, bends, and even drainage patterns. And yet, when found, it can reward persistence with extremely pure, fine gold that most others overlook. But only if you understand how ice, not water, delivered it. Unlike traditional placer deposits, glacial gold isn't sorted by water flow. It arrives by force, pushed, crushed, and smeared across terrain as ice sheets move southward during the last ice ages. In North America, that means vast parts of Canada and the northern US, from the Yukon through British Columbia, down through the Midwest, and into parts of New England and the upper Great Lakes, were covered and reshaped by advancing and retreating glaciers. These glaciers scraped across hard rock formations, plucking gold-bearing material and grinding it into everything from flour-fine particles to rough pickers. The result? Gold scattered across ground moraines, drumlins, eskers, and outwash plains, not always near rivers and rarely in concentrated pay streaks. The key to glacial gold recovery is understanding where meltwater left behind density traps. These aren't stream bends, but rather kettle holes, till plains, gravel ridges, and even buried paleochannels now isolated from modern drainages. Sampling glacial gold begins with terrain recognition. Eskers, long, snake-like ridges of gravel laid down by subglacial streams, often contain sorted materials. Within these, gold can concentrate in pockets where flow velocity dropped. Kettle holes, depressions left by melting ice blocks, can also act as catch basins for gold-laden meltwater. Look for gravels with clear signs of water sorting, stratified layers, coarse bottoms, and black sand pockets. Because glacial gold is typically very fine, gear choice becomes critical. Standard pans often lose ultra-fine flour gold. A blue bowl concentrator, gold cube, or multi-layered sluice matting design for fine recovery dramatically increases yield. These systems allow for reprocessing of concentrates, essential when you're dealing with gold particles smaller than 150 mesh, less than 100 microns. Density remains your main advantage. Even flour gold will eventually settle with magnetite and garnet in fine gravels. Use classifiers to reduce turbulence and increase separation efficiency. And if possible, work in a recirculating setup. Glacial areas often lack running water, especially in elevated moraines or remote cuts. Purity is the payoff. Unlike some river gold, which can be alloyed with silver or copper, glacial gold is often scraped directly from lode sources and remains high in carottage, typically 90 to 95%. The downside is recovery difficulty. You'll need patience and multiple refinement steps to accumulate saleable weight. Tracking gold's origin in glacial zones also requires backward thinking. Instead of following a river upstream, you study the glacial flow direction. Maps of ice advance, terminal moraines, and erratic patterns show where the ice came from and where it dragged gold along. This method has led to the discovery of entirely new deposits in parts of Saskatchewan, Wisconsin, and Maine where no bedrock sources exist nearby. One final trick. In former glacial zones, bogs and peat layers can conceal ancient outwash gravels beneath. Digging down through organic muck often reveals well-preserved gravels loaded with black sand, and sometimes gold, especially near the base of kettle depressions. But glacial work comes with risk. Terrain is often unstable, water is scarce, and access can be rough. That's why understanding when to work these zones, based on season, runoff, and exposure, is as important as knowing where. Gold moves with water, but water moves with weather. And in gold panning, timing your work to seasonal shifts and storm events can mean the difference between an empty pan and ounces of new deposit. Most hobbyists think only in terms of access, whether the stream is dry enough to work. But true recovery depends on understanding when nature is doing the heaviest lifting for you, and when it's erasing everything you've mapped. Let's start with the most productive window, post-runoff, early summer. In snow-fed regions, spring melt sends torrents of water downstream, scouring riverbeds, shifting boulders, and redistributing gold. Large floods break up compacted gravels and expose fresh bedrock traps. As water levels drop, those freshly worked gravels settle, often creating new surface-level pay zones or revealing old ones. Timing your dig to just after water recedes, but before sediment settles again, allows access to redistributed material without heavy overburden. In glacial or alpine regions, the same applies on a shorter scale. Diurnal melt cycles, where snow and ice thaw during the day and freeze at night, cause rivers to rise and fall predictably. The best sampling happens early in the morning, when flows are lower, exposing more riverbed and allowing safer access to central channels and inside bends. But flood logic cuts both ways. If you're working a section of river and a storm upstream sends flash water your way, your dig site can be destroyed in minutes. Flash floods, particularly in desert washes or narrow valleys, are deadly. Always scan for recent debris piles, high watermarks, or undercut banks before digging. If there's thunder upstream, even if the sky above is clear, evacuate low zones immediately. On the flip side, drought can hide opportunity. In years of unusually low water, entire sections of river normally submerged become accessible. Exposed bedrock, sunken logs, and ancient riffle zones appear for the first time in decades. These areas are often rich in trapped gold that hasn't moved in years simply because no one could reach them. Pay particular attention to mid-channel boulders with crevices on their downstream side. Classic catch zones that rarely see a pan. Season also governs substrate workability. In early spring, high water and frozen layers make deeper digging impractical. In fall, sediment may be compacted or baked hard from sun exposure. Moist, freshly deposited gravels are ideal for processing. Easy to dig, yet not so loose that fines escape your pan or sluice. Temperature matters too. Many fine recovery tools, like recirculating sluices or gold cubes, rely on pumps that struggle in cold water. Below 40 degrees Fahrenheit, batteries lose efficiency and water viscosity changes enough to reduce fine gold recovery unless properly adjusted. If you're working in sub-freezing temps, focus on spot testing and mapping, then plan your serious recovery for warmer days. Barometric pressure can even hint at opportunity. After a sudden drop, just before a storm, animals retreat, human activity slows, and rivers often clear as sediment settles. While risky, this narrow window can be a chance to grab fast samples from usually clouded water. The takeaway is this: every gold-bearing stream has windows. High flow, low flow, first freeze, post-flood. The pros time their work to when nature sets the stage, not just when it's convenient. And if you're logging samples, weather data should be right alongside grid coordinates and yields, because what you find one day may be buried the next, or revealed if you know when to return. But before you start scaling up based on your best weather day, make sure you're even allowed to dig there. Because no matter how rich a site looks, legality and access will define what you can keep, and what could cost you everything. Gold panning has a romantic image: solitary explorers, riverbanks, and free discovery. But modern reality is governed by layers of regulation, permits, and land status. Digging without understanding those boundaries isn't just risky. It can lead to confiscated gold, steep fines, or criminal charges. Whether you're sampling a creek or staking a long-term claim, legality defines what you can take, where you can go, and how you can scale. The first distinction every prospector must make is between public and private land. In the U.S., vast swaths of federal land are managed by the Bureau of Land Management, BLM, or the U.S. Forest Service. These lands are often open to recreational panning, provided you use non-motorized methods and don't disturb stream banks or aquatic ecosystems. However, once you switch to high bankers, dredges, or any gear that alters flow or substrate, you likely cross into regulated activity, which requires permits. Each state adds its own rules. For instance, California allows recreational panning in many public areas, but tightly restricts motorized equipment and prohibits work in certain salmon habitats. Oregon and Washington issue timing windows for in-stream work to protect fish spawning. In Alaska, many productive sites lie on native corporation land or require state permits, even for hand tools. In Canada, each province governs mining rights differently. In British Columbia, you can pan without a license on unclaimed Crown land, but as soon as you want to sell your gold or use mechanical tools, you must acquire a free miner certificate and potentially stake a claim. In Yukon, panning is legal on public land, but many gold-bearing zones are already under lease or First Nations jurisdiction. Trespassing here is a serious offense. One universal mistake is assuming unposted land is unclaimed. Many active claims have no visible signage, especially in remote areas. The only way to verify status is through official databases. In the US, the BLM's LR 2000 system lists active claims and owners. In Canada, provinces like BC offer online maps such as MTO, Mineral Titles Online, that show staked ground. Always cross-reference GPS coordinates with these systems before sampling. Ignorance won't protect you. Then there's water law. Even if the land is public, riparian rights may restrict access to the waterway or limit material removal. Some jurisdictions allow you to rearrange gravel, but not to remove it. Others prohibit you from digging below the high water mark without a permit. Many areas define a difference between casual use and disturbance, the latter requiring environmental review. If you do decide to stake a claim, be ready for obligations. Claims often come with annual assessment requirements, proof of work or payments to maintain legal control. Failure to meet these can void your rights, allowing others to restake the ground. Some areas also require posting visible claim markers, filing detailed location notes, or submitting sampling results with your paperwork. Selling gold, too, has legal implications. In small quantities, most regions allow recreational prospectors to sell without registering as miners. But consistent sales, especially with recorded yields, may require business registration, tax reporting, or royalty payment depending on local laws. Selling gold across borders, like to refiners in another country, can trigger customs issues if not declared properly. Ultimately, being legal protects your find. It allows you to record, return, and even scale your effort without fear. More than that, it gives credibility. If you seek a partner, investor, or buyer, having a clean paper trail, from sampling logs to claim status, makes your gold worth more.